It's a huge blow, obviously.
Alright, I'm back with another video. We're looking at graphing other trig functions, day 2. We're going to look at tan and cotangent. So let's start with tangent. I went ahead and put the scale down there for tangent, guys. Okay. The tangent graph is by fourths. I also reduced each fraction. So here we go. So we have here our y-axis and our x-axis. Whoa, that didn't happen right. Let's just go over. There we go. Y-axis and x-axis. Now, if you remember, you have the unit circle. Alright, and with the unit circle, remember tangent of theta equals sine of theta over cosine of theta. Well, the reason I'm pointing this out is because here's where the points come from. Alright, if you had an actual chart and you want to find theta, alright, of tan theta, excuse me, you want to find your points. Alright, you'd have 0, 0, because at 0 degrees, alright, the point is 0 over 1, excuse me. Alright, 0 over 1 is 0. Alright, so we have the point 0, 0. And then if I kept working and I had this angle right here of 45 degrees, so if I had this angle right here of 45 degrees, remember that radian was, that point was radical 2 over 2, radical 2 over 2. Well, if I found tangent, sine over cosine of radical 2 over radical 2, that would be 1. Alright, that would be 1. Alright, and then over here, for negative pi over 4, down here for negative pi over 4, again, those points would be negative radical. It would be radical 2 over 2. Negative radical 2 over 2. Alright, I know it's supposed to be in parentheses, but there you go. Alright. So anyway, that would be negative 1 if I found tangent. Alright. And the reason I did this is because I want you to see where these points come from. And if I kept going throughout the whole unit circle, throughout the whole unit circle, you'd see how I got all these values. But anyway, this will continue if I went to like pi over 2. Alright, pi over 2 is point 0, 1. So if I found tangent, it would be sine over cosine, which is undefined. So that is undefined. So right here at pi over 2, which is 90 degrees, 0 over 1, 1 over 0 is undefined. So there's an actual asymptote right there. So let me draw an asymptote real quick. Right there, pi over 2. Alright. And this would continue. It would be another asymptote of 3 pi over 2. And of course, there would be an asymptote at its negatives angles as well. Alright. So now, if I were to find a point at 3 pi over 4, which is right there, alright, you'd see that that point was negative radical 2 over 2, positive radical 2 over 2. And if you found tangent, it would be sine over cosine, that would be negative 1. And then at pi, over here, right here, you have the point 1, 0, or negative 1, 0, which is 0 over negative 1, therefore it's 0. I don't know why I'm using that color, I need to use another color. And then if we did this one right here, you'll have a negative over a negative radical 2 over 2, which will cancel out and be positive. So anyway, man, and if I kept going, this pattern would be the same. I'm just trying to explain to you how these values actually exist. Alright, so when you grab this thing, it approaches infinity like that, but it never crosses those x values. And again, right here, it never crosses those asymptotes. Excuse me. Oh, too far. Let's fix that side. Right there. Never crosses those asymptotes. So this is tangent, guys. Alright. This is tangent, and this is why it exists. Alright, in a nutshell, a very simple explanation as to why tangent theta exists. Alright. So now we can answer questions. Alright, find the amplitude. Oh, guys, there's no amplitude. Alright, reason being is because the distance from the midline to the top is infinite. Alright, so there's no amplitude. And the period, if you look at the table, you'll see that this is from negative pi halves to pi halves, or from pi halves to 3 pi halves is the distance of pi. Alright, so the width of one cycle is going to be pi. Alright. And then the asymptotes, again, we can look at the graph. Negative 3 pi over 2, negative pi over 2, pi over 2. And again, they're all the distance of pi. So we're going to define that as pi over 2 plus or minus pi n for any integer n. For any integer n. Alright, we're just going to do like a cheat. There we go, for any integer n. Okay. Now we look at cotangent. Alright, cotangent, on the other hand, is the inverse of sine. Okay, it's the inverse of sine. So, if we were to look at cotangent on the unit circle like we did earlier, and let's look at this one. Alright, 0 degrees. Well, that point is 1, 0, excuse me. So if I went cotangent would be cosine over sine. That's undefined. Alright, so at 0, we're going to have an asymptote. So let me get my different color going here. And there we go at 0, we have an asymptote. Alright. And then if I were to look at, let's say, 45. Alright, well that's radical 2 over 2 over radical 2 over 2. Alright, so cotangent over sine would be 1. Alright, so we have pi over 4 is 1. And then if we look at pi over 2, 0, 1. Cotangent would be 0 over 1, which is 0. So pi over 2 is 0. And then 3 pi over 4,
You played that boy.
which is right here, would be radical 2 over 2, comma radical 2 over 2. And cosine over sine would be negative 1. Like that. Alright. And then if I did this point right here, negative 1, 0, I found cotangent, that's negative 1 over 0. So that will give us undefined as well. That's undefined. So we have another asymptote right here at negative pi. So, there we go. And again, that's the distance of pi. So if I went the other way, we'd have the same condition. Alright. And you can check all these the same way I just did. It'll work out the exact same way. So this is how we get our graph tangent and cotangent. Well, this one's cotangent, so boom, can't cross the asymptote. Man, I'm terrible at drawing these connecting dots. Alright, and one more. Alright, so now we have it drawn, we can answer questions. This is cotangent, guys. Alright, this is tangent. Now, the amplitude again from the midline to the top is non-existent. There is no top, so none. The period from 0 to pi is pi, so the period is pi. And I say 0 to pi because there's an asymptote here and an asymptote here. Alright. And then the amplitudes. Where are the amplitudes? Well, the amplitudes lie on any pi n value. Alright, for any integer n. Because this right here, 0 is at 1 pi, is at negative 1 pi, it would be 1 and 2 pi. So n pi for any integer n. Alright, n pi for any integer n will define where the asymptotes are for this graph. So now, before I move everything, I want to answer a couple questions. The first question is, tangent of theta equals 0. Where does theta equal 0? So if I go to my tangent graph, and where does tangent equal 0? Well, here's 0, here's 0, here's 0. So how do we answer that question? We're going to say, look at this, that's 1 pi, 0 pi, negative 1 pi. So that means this exists at any n theta equals any pi n for any n for any integer n. Alright, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 7 pi, 9 pi, there's a theta. And then right here for the theta, where's theta undefined, where's cotangent, excuse me, of theta undefined. Alright, well, it's undefined as asymptotes.
Nigga, you played that boy.
So where are the asymptotes? Well, if I go to the cotangent function and I look at where the asymptotes are, which we also just defined, down here we'll say n pi for any integer n. Alright, look at it, negative 1, 0, pi. So we say n pi, and again this is cotangent, not tangent, n pi for any integer n. Alright. Alright, another question. tangent of 4 pi. Well, if you remember how tangent graph works, tangent of 4 pi, if you look at all the n pi's, right, 0 pi, 1 pi, negative 1 pi, right, we see that all the n pi's are 0. So what would be, what would be tangent of 4 pi? 0, alright, because it's n pi. Any n pi on the tangent graph is 0. And a cotangent, which is cotangent of 5 pi over 2. Well, if you go to our cotangent graph, find 5 pi over 2. Alright, what we can do and analyze this is, so what is cotangent of 5 pi over 2? Well, if we look at our cotangent graph, and we look all the n pi's, all the pi halves, alright, or cotangent, are 0. So 5 pi over 2 would be no different. 5 pi over 2 would also be 0. 9 to 5, sorry. I was looking at the tangent graph earlier when I made the key. But 0. Now, a couple more things we gotta look at is the actual transformations. Alright. We have 2 transformations here. We have an amplitude 2, and we have a a phase shift right by pi halves. So what I like to do is I like to move the asymptotes by half, pi half. And just so you can have a reference, if you look at tangent, cotangent. If you look at tangent, you'll see that if you move all the asymptotes by half, right, you'll see this is a period of pi. So if I move this by half, it's going to be here. And if I move this half, it'll be here. Move that half, it'll be here. So all the points are going to move over 2 lines. So 1, 2, 1, 2, 1, 2. Alright, that's half. But also, we got to stretch it by 2. So let's move the asymptotes first. Alright. So let me go to thick line. So remember, all the tangents are at pi halves. Well, we're going to move them by half. So let's move the asymptotes. So I'm going to move the asymptote to the right by half. So what was once right here at pi halves is now right here. Alright, and the one that was right here is now right here. And then there's another one right. Whoa, didn't mean to do that. Sorry about that. There's one more right here. Man, that drawing is terrible. There we go. Alright, man, I'm sorry about that. Now, all those points have moved over as well, but you gotta stretch it by 2. Alright, so this point right here, see how this is 1, 1, oh, sorry, power 4, 1. Well, 1 times 2 is 2, so it's going to move right twice to 3 power 4, and then up 1. Alright, and this one will move right twice and down 1. So power 4, negative 1, and 3 power 4, 2. 4, -2. 0, 0 won't change, and then there we go. And we just repeat that pattern throughout. Ooh, spacing is off, but it's not okay. So we have tangent right here. Like that. Man, alright. We're graphing tangent. Now guys, again, you gotta pay attention, man. The transformations, I don't get it. Idea, alright? It's not gonna work here, man. Like, it's all the same transformations we've been doing. We're just moving different things. And you can very well move these. I promise you can do it. One more example. Let's move cotangent. Alright, so this time we're going to move it to the left by halves and then down 2, excuse me. So if you go back to the cotangent graph, alright, you'll see right here that we've got to move all the asymptotes by half to the right to the left, excuse me. So this will move here. It's going to move right here. Negative by halves. Because it's 0, these are easy to move. So 0 to negative by half. We're moving it by halves. Pi to by halves. Alright. So yeah, let's just move. It was a little easier to move. Alright, there we go. So left by half. And then all the points are going to move down 2. Alright. So where we had this point at 1, alright, it's now right here. Oh, let's use another color. Alright, we'll put this point was at 0, down 2, and this point was at -1, so down 2. We'll just repeat the pattern. Like that. We graph it. Man. Alright, and one more. So well, that concludes our video, guys. I really hope this helps you, and I will catch you later.